Picking up where we left off, it's time to define what typecasting is. Simply put, typecasting is the act of taking every element out of an array and changing it to a specified data type. For example, we might have two integer arrays, but want to store their sum as floats because you intend to conduct float operations later. In that case, you'd be better off casting the output as a decimal rather than a whole number. To put this in practice, copy the code from the last cell into a new one and add dtype equal to np.float64 in the parentheses. The output matrix contains the same numbers as before, but is displaying them as decimals rather than integers. We can also change these integers to complex numbers or any other type we examined earlier in the section. However, it's important to understand that this does not only change the result, but rather changes the inputs themselves. This is most obvious if we set the type to strings. If we do so and run the cell, it results in an error because the function converts all numbers into strings and then tries to add them up, rather than adding them up first and converting them into strings later. Great! To finish this concept off, note that casting is very widely used and is the preferred way to unify data types across a project. The last feature we want to discuss is running a function along a given axis. Essentially, this means that NumPy breaks down an ND array into smaller arrays of n-1 many dimensions and applies the function to each one. Therefore, we can take a matrix and use this feature to run a function along each row or column, depending on what we're looking for. Since the add function can't be applied along an axis, we need a different function here. For this example, let's use the mean function and pass matrix C as an argument. Then, set the axis argument to 0. This means we're finding the mean for each column of the array. Therefore, the output is an array containing 3 values, one for each column of the matrix. To check if the results make sense, let's output matrix C on a new line. We see that the values in the first column are 1 and 4, which means their sum is 5, and their mean is 2.5. Similarly, the mean of 2 and 5 is 3.5, and the mean of 3 and 6 is 4.5. This is useful when we have a large array where each column holds the values for a different category, and we can find the mean of each one with a single command. Nice! Of course, we can also switch the axis to 1. That will result in us getting the mean for every row in the matrix. The result is an array containing the values 2 and 5, which are also the means for the first and second rows of matrix C. Fantastic! We've already learned about using typecasting, broadcasting, and running a function along a given axis. These 3 features are standard for NumPy functions, so it's great that we can apply them in our work with the package. Now that you've been introduced to the fundamentals of the NumPy package, you're ready to begin working with arrays. In the next section, we'll examine key notions of ND arrays like slicing and the squeeze function. Thanks for watching.